Charles Pilson is a principal at the Kercher Group, in which position he works with state agencies in managing their assets and optimizing asset investment trade-offs. He previously was a senior project engineer at Agile Assets. He is an active in TRB and chairs the technical committee on maintenance management systems. Our final speaker of the session is Charles Pilson.
I'll kind of echo the other folks here. Good afternoon / good morning to everybody. This particular presentation is about using available data to make decisions. I'm Charles Pilson with the Kercher Group. Of course, echoing the other folks, just want to thank Patty and Judy for inviting me to take part in this. Excellent. And the other thing I'd like to say before I get started is that very rarely have I found that my particular presentation fits so well into the other presentations and in the right order as well. So I just want to thank Lauren and I'm going to call them the two Larrys, Larry the younger and Larry the elder. Hope you guys don't mind that. Maybe it's like Pliny, are they Latin philosophers there? Absolutely perfect. And so I think this particular presentation is going to go back more to LT's presentation there, which is more on the lines of asphalt pavements. But I also want to mention that Larry Schofield there, one of those folks that he put up there, Ron Hudson, he was my PhD supervisor. So, you know, come from that long background. Some of those photographs of the road test I've seen many times. And I would also like to say that I used to play squash with Ralph Haas's son, Carl, while he was at UT, at University of Texas there. And I used to beat him every time, but he was on my PhD committee. So I thought, you know, at some stage I better stop beating him at squash and so that he would let me get through there. So anyway, that's a little bit of background, very interesting. So I'm going to dive in here. What is this this particular presentation about? Well, officially it is about you know, using available data to make decisions. Well, one of those sources of available data for flexible payments anyway these days, actually rigid payments too, is the automated detection of cracking, and that's, you know, by systems like LCMS, laser crack measurement system. That's not the only one out there, but you know, this presentation then is about some of our experience with that and how we've used that kind of LCMS crack tracing information in pavement management systems, pavement management system implementations. So, you know, what we've essentially been doing is transitioning away from some of the visual survey style that we've been using for so long and using this new metric we call crack density. So crack density there is what I'll explain in a bit here. But the other part about it is that we're also doing this at incredibly high resolution. So you'll see that we're down, you know, looking at 6 foot, you know, little segments longitudinally, and then even splitting it up transversely as well. And so, you know, being able to take this data and make preservation decisions in a pavement management system really, really is starting to become doable now. Why? Because those, you know, those measurements, that kind of crack tracing measurement, you know, translated into crack density, is really, really accurate and repeatable. The other thing about it is that it's distribution based. This predictable side of it, you know, you can actually model those distributions as well. So we'll go through all of these things, you know, during this presentation here, but really kind of looking to the next generation here, really trying to change the way we look at this information here. That's what we've been doing, you know, just recently in a few of our projects, is really changing the thinking. Cracking, you know, has always been one of those problematic distresses that has been really hard to really get quantitative about. Traditional distress definitions have always revolved around really being able to do this stuff visually. You know, you look back to the good old ASTM standard on the right here. You're looking at, you know, trying to gather information about, you know, how much area you've got in terms of alligator cracking and block cracking and longitudinal cracking, transverse cracking. It's all geared towards visual surveys. And so, you know, when I first started out, kind of harking back to the Ron Hudson thoughts there, you know, 25 years ago, this was just not possible, you know, to the extent that we're able to measure cracks now in pavement surfaces. And so what we really started thinking about was, what if we were to be able to now use what this new technology can do really well? What if we really just went with what that technology is good at, as opposed to really trying to get back and map everything back to those visual surveys? And so we're looking in here about what if we could kind of move beyond visual surveys? What if we can really use that pavement cracking data directly into these indices that Larry was just talking about, into these separate indices, and really collect that at a very high resolution, and then have that go straight into the pavement management system without going through a lot of these distresses, which really came through from the visual side of things. So the first kind of document, if you like, that is going to be part of your data collection. All of the folks out there, have probably sourced out their data collection in some form or fashion. Well, one of those documents, to define what that's going to be, is your data dictionary. And so as part of the data dictionary, we're starting to look at some of these things where we're starting to dive down into looking at crack tracing, and look at it on a very fine level of detail. So, in here you can see this is actually a 6-foot segment. I'll blow this up in a second. So longitudinally, you're looking at 6 foot, and then even transversely, you can look at the different zones. And these are the classic R85, AASHTO R85 zones. The bottom line is you can see that machines are getting really, really good at this stuff now. And if we dive into a little bit more detail here, you can take one of these little panels and say, what is the crack density within that panel? And it doesn't really matter exactly how big the panel is, or how wide it is, or how long it is. In the specifications that we've been kind of using or pushing out lately, we've been looking at a 5 to 7 foot segment. Some of the data collection folks out there use 2 meters. It's right there at the 2 meter level. Longitudinally. Transversely, you can see you've got the R85 zones here. These outside zones, 1 and 5, are really, really small on this diagram. But here are the 2 wheel paths. This is zone 2, zone 3, and zone 4 here. And really, being able to get the crack density within any one of these individual little panels here. So now we can start getting away from these little green boxes here, where you're using AI to try to identify transverse cracks and things like that. You're really looking at the cracking in terms of both its width and its length. So you can see some of the orange coming through here on this diagram, indicating a slightly wider width. And you can also start seeing that this crack density thing, which is the length of cracking per square yard, is a sort of normalized metric that we can now start using. So, I put LCMS up here. That's really just kind of one of the technologies really starting to dive into that level of detail. And the reason that we're really doing this is because when you sort of take the human side out of it, whether that's, looking at this stuff visually and coming up with all these different distresses, or if you're trying to put it through some sort of AI, some sort of artificial intelligence, and coming up with those traditional distresses, you're still leaving a lot to chance. And based on what we've found in a lot of the investigations we've been doing recently, that AI side of it, even though we're measuring the kind of raw crack lengths and crack widths here, once you start putting it through those AIs, granted they're getting better, but that's where a lot of the inaccuracies come in, and the repeatability problems come in. Because once you get into kind of translating what is that crack pattern within the box there, the differences between block cracking and fatigue cracking. When does block cracking become fatigue cracking? And it's very hard to draw those exact lines. Really kind of bypassing that step is what we've been doing some of recently here. In the data dictionary, you're starting to look at capturing crack density per each one of those individual zones per 6 foot segment, 2 meter segment there. The other document that is going to be typically part of your procurements these days is this data quality management plan, the DQMP. Recently, the feds required that. The FHW's required that as part of the 490 legislation there. So that's been something that everybody's been kind of dealing with. And so typically, you know, the data collection vendors are going to be asked to kind of be able to handle these DQMPs as well. So let's just quickly have a look at these DQMPs. In some of the recent procurements that we've kind of been involved in and implementations, you know, pavement management implementations, we've been looking at not just crack density in general, but crack density in two kind of severities here. So one of the things that LT talked about in his talk there was, you know, crack sealing and things like that. Because we're able to do this now, we can actually get the crack density for crack widths less than 0.25 of an inch, you know, quarter of an inch, and then crack densities for cracks greater than quarter of an inch there. And that quarter of an inch being, you know, kind of where we can say on the one side, where, you know, it becomes, say, a crack sealing candidate, on the other side, maybe not. We're now getting, you know, two severities for every 6-foot segment across 5 zones. So incredibly high resolution of data now. It's all just data, you know. We can pull that in, and we're kind of summarizing it, as I'll show in a bit here. The essentially the data quality is revolving around capturing crack density at this kind of level. We also, you know, have total crack length, you know, because obviously it's nice to be able to layer up here a little bit, and then things like alligator and longitudinal and transverse, we actually still have in there, just because this is a little bit of a new thing for everybody, and we wanted to make sure that we still captured some of the traditional distresses, obviously. But we're seeing a lot of correlation that we can make between being able to work with this data at this level of detail and translating it into alligator, longitudinal, etc., transverse, etc. And so just kind of working our way to the right here through the diagram, you know, obviously this is the unit of measure here. So crack densities being measured in foot per square yard. Protocols, you know, traditional protocols there, talking about the resolution, you know, to the nearest 0.01 feet per square yard. And then the accuracy and repeatability. And the accuracy and repeatability are actually, you know, very, very good, I would say, compared with a lot of our tradition. And we've done a lot of visual surveys in our time. I've done a lot of visual surveys in my time. And I would say that, you know, I could go back to the same pavement, you know, 2 days later and get completely different answers. Not completely different, don't get me wrong. But, you know, the accuracy and repeatability of this data with this new technology is really quite amazing. That's just a few words about the DQMP, the Data Quality Management Plan. Really, the high-level takeaway here is that we can now start asking for very high levels of accuracy and repeatability on this kind of data. Of course, those two documents really sort of end up in some sort of procurement. I stuck City of Raleigh up here just because that's where I happen to live, and so that's where I'm talking to you from. The RFPs now can really ask for this data, ask for the vendors out there to be able to collect this data with these high levels of detail. But the reason that we're able to ask for this and expect relatively competitive prices on this data collection is that it's incredibly automatic. So you can see that there's not a lot of you know, poring over this by actual people sitting at computer screens and looking at this stuff. Crack tracing, if you like, crack lengths and crack widths, that's just coming straight out of the technology. I mean, it's just coming straight out directly. And so that post-processing into those 6-foot segments across those transverse zones is, you know, can be very, very automatic, totally automatic, I should say. So as a result, you know, we can still rely on some of these established protocols, you know, R85 crack definitions and the zones, but because it's very automatic, that information or that data collection is still very cost competitive. Moving into how to maybe start being able to use this in a pavement management sense, to connect it a little bit back with Larry Schofield's previous presentation there, even though we're kind of probably more talking about asphalt here than rigid, we've also started to use some of this in a rigid environment, rigid pavement environment as well. But, you know, this presentation very firmly focuses on asphalt, flexible. One of the things that Larry was just talking about is, modeling and measuring all these different indices individually, and rather than going to these kind of composite indexes. We still like these composite indexes just because, it really just kind of gives you an idea of overall health, if you like. But when you're making pavement management decisions and you're really trying to pull out information to actually choose a particular treatment, going back to LT's presentation, then you need this data at a much more kind of higher level of detail in terms of these indices. And even here, even with this crack density index, that can be broken down, and you can actually look at projecting individual components even of the crack density index itself. We're able to really model that crack density progression over time, and I'll show you that in a second here. And by being able to model and predict, going back to John Wilcoxon's early presentation there, you're really able to start looking out into the future and start planning ahead and kind of look at those optimal mix of fixes that you want to be putting in your tamps and things like that out into the future. But you can be making those decisions on really quite a high level of detail these days in pavement management systems. Kind of looking at the crack density index, we can then start breaking down even that crack density index into different severities, for instance, extents of different severities. We'll kind of dive into that in a second. This is, very new for us and very new for some of the folks that we've been working with. But, we're very excited about it actually, and certainly see lots of potential for this. This slide here actually talks to this crack density really coming from a long history. So there was a paper by Patterson many years ago, actually a compadre of Ron Hudson and Ralph Haas's, interestingly enough. He really kind of was way ahead of his time in this area. And he kind of, at the time, there was no technology to really be able to do this crack tracing really well. Certainly not this ability to kind of use 3D laser scanning and look at the ability of being able to measure the lengths of different widths even. So he was way ahead of his time, but that's what he foresaw. And some of this, this crack density stuff is really building on work that he did many years ago. The idea that you can then take this crack density and look at severity and extent, again, a lot of the folks on this, listening to this presentation, will hark back to severity and extent being used for many years through pavement management history there, and being able to do that is really now becoming very possible at a very fine level of detail. Really, that cutting straight to the chase there is just about actually being able to somewhat shortcut and not have to go through all these visual distresses necessarily. Again, a little bit experimental, I will grant you, but able to really use what the machines are really good at, and ultimately producing this really accurate, repeatable quality data. The point of the slide, though, is that these kind of new ideas come from a long history, but are actually being built into a brand new ASTM standard, where we're sort of looking to, let's just say, supplement, because not necessarily replace, right? There's still going to be visual survey going on all over the place. But let's say supplement the original ASTM standard and start looking to these new technologies and be able to start looking at a crack density type of index. You can look forward to that new ASTM standard coming down the pike. I've been very interested in taking part in that whole process, and so very interesting that this is not just something that we've been working on ourselves. All right, so let's kind of dive into some of this distribution-based decision making. So if you think about what we're trying to do here, we're trying to capture crack density at this incredibly high resolution level. I'm sort of showing on this slide some very basic severity and extent kind of information. It hasn't been broken down, for instance, into wheel paths and non-wheel paths. There's lots of future potential for this. So this is a relatively simple implementation here. And what we're looking at is really just crack densities, along the pavement in those 6-foot segments, using that 6-foot segmentation, and looking at deriving different quantities, different extents, if you like, for different severities. So starting out at the top here, number one, just kind of focusing on some of this. Let's just go across the top here. So these are for, each row here is for an individual pavement section. So, you know, in pavement management, you're looking at pavement sections being anywhere from, you know, if you're looking at sort of urban environments, they might be all the way down to 0.1 of a mile maybe. But, you know, in typical rural environments and for state DOTs, often you're looking at, you know, kind of 10th mile, half mile, 1 mile, heck, you know, even longer than that. But you're managing your roads at this kind of section level. And so I was careful to say segment when we were talking about, you know, capturing this 6-foot segment level data down here. So each one of these rows here is a section, and then within that section, you can see that we can now pull out the percentage that has zero cracking, you know, in terms of crack density. We can pull out crack densities between 0 and 5 here. So in this particular top row here, that's 31.6% of the pavement area has a crack density between 0 and 5, and so on and so forth. 3.8% of the road section has a crack density between 5 and 10, between 10 and 30, and then greater than 30. And then kind of for grins and giggles, you can do these little spark lines, which Excel has, to be able to look at this in terms of a little bit of a distribution here. So you can see the top one here is most of the pavement is in, you know, a state where there's no cracking at all. There's a little bit of low severity crack density, and then there's zero pretty much down towards the right here of high severity crack densities. So that gives us a kind of overall PCI, if you like, by the way, combined with things like rutting and roughness, of 92, let's say. And the next one down here, you can see 19% of the pavement has no cracking, but more of the pavement has kind of low severity, 0 to 5, 42%, and going to the right here, 18, 18, and 0.77. So you can see there a little bit more cracking going on in that pavement section, right? So obviously you expect to see a little bit of a lower PCI overall. But point being, while you're looking at these high level kind of condition indices, these kind of composite ones that Larry just talked about there, you're also tracking and modeling at an incredibly high level of detail over here on the left. Let's just look at another section here, kind of this block here, which I've labeled 2 here. So in this case, and let's just focus on the spark lines here, you can see all of these have pretty much the same shape, right? They're all got a lot of extent over at the far left severity level, which is zero cracking. So these are very good, you know, at least with regard to cracking pavements, and so therefore they show up as relatively high PCIs. If you drop down a level down into this kind of area here, you can see these pavement section IDs have a lot more problems, right? So these spark lines have a completely different shape to these spark lines up here. They're all weighted much more to the middle and possibly even to the right, where you can see much higher extents of higher severity crack densities. So, you know, just maybe taking the very top one here, you've only got 4.9 or 5% of the pavement with zero cracking in it, 5% of those little segments, but you've got, you know, 24% with 0 to 5, 14, 5 to 10, but then you can see that half the pavement sections, or half the pavement segments, I should say, have a pretty high crack density here, between 10 and 30, but you don't have any really high severity stuff just yet, so probably no real severe alligator cracking just yet. And that holds true for some of these other ones here. Some are slightly better than others. But as you can see on the right here, we've been kind of translating this extent severity on crack density and, you know, combining it with rutting and roughness to be able to come up with a PCI, which really helps, you know, kind of owners, if you like, just kind of have a look at the general overall state of their pavement. But the point being is that we have all this really detailed information to be able to start making pavement management decisions on. You know, just thought I'd kind of go through some of the detail here, just stick up an example. So right out of the gate, just by getting a survey like this done to start with, you already have access to this level of data. What the future holds for us, though, is because of the accuracy and repeatability of this kind of data, you can take any one section and say, how does the extent severity kind of progress over time? And so in this next slide here, you can actually start modeling all those individual severities individually. And so, perhaps some of the folks listening to the presentation there have come across Markov modeling and all that kind of good stuff. Well, it's not rocket science. All you're doing is really measuring and modeling the individual extents of the different severities. So let's kind of take, this kind of cross section, if you like, at 1 here and look at the different severities. Well, so that gray is the 0 to 5. So you can see that maybe early on, most of the pavement, some of the pavement is going to be wandering up into the 0 to 5 level, but a lot of it is going to have no cracking at all. But as low severity cracking starts increasing, you can see that some of it might have the 0 to 5 level here. In the next severity, the orange curve here, if you like, you can see while this is going down, this is starting to creep up. The next severity level is starting to creep up. Same with the blue severity level, the 10 to 30 kind of bucket or bin, if you like, starting to creep up. And then lastly, that really severe kind of alligator cracking level density is sort of typically very, very low to start with, but you might see parts of the pavement kind of starting to locally get bad as that super high severity crack density there starts progressing. So, maybe as you progress over time, you can see again the low severity bins kind of decreasing. The next one up, it gets higher, but then as those little areas on the pavement start transitioning into higher severities, they also start to tail off. So you can see for the yellow and the blue there, these middle crack density bins, they get a little bit higher to start with, but then as they start transitioning into the next state, into the higher severity states, they start to go down. And of course, that really high severity state there just continues to increase over time. And if you let that go all the way through, you're going to see you're basically going to see most of your pavement in that really, really high severity state. So this is this is not real data, by the way. This is purely just me playing around in Excel. I think the point being is that not only can we measure at this level, at these individual crack density severity levels, and be able to really make decisions in the immediate future on that, we can also model those severities out into the future. And so that's also really exciting. I will say one last thing before I move off this slide, because one of the things about pavement management is predicting not only deterioration over time for whatever you're measuring, whatever your metrics are, but it's also about predicting what the treatments that you're putting on your roads actually do for you. So how does putting on a particular preservation treatment affect these different severities of cracking? So you can imagine if you put the wrong treatment on the wrong road, again, thinking back to LT's presentation there, if you have some really wide cracking out there, you put fog seal on it, you're not going to do anything to that wide cracking. So you can now model exactly what a particular treatment would be able to, would be doing on your pavement in terms of these severities. And of course, once you've got some of that really wide cracking out there, you're going to have to do something like a scrub seal or crack sealing. So the ability not just to project the deterioration of what's going on out there, but also to predict the improvements that you're going to get from certain treatments is extremely important in some of this pavement management that we're looking at here. With that, I'm going to finish off then and really just kind of look at some of the things that are possible now. If you can really do that distribution-based data collection and prediction, then you can really make these kind of candidate decisions based on both the current levels that you're measuring, and of course, if you get your models right, you can also be making those predictions out into the future, really on the basis of extents of different severities. Some just very basic examples here. If you've got no cracking distress at all, but your pavement age is maybe between 1 and 5, probably on the earlier end of that, as LT pointed out, well, you've got a rejuvenator candidate. But notice that just within that, if you did happen to have some just very localized areas of super high severity, high crack densities, well, they might be, candidates for local patching or something like that. No severe cracking, but, sort of light, very narrow cracking throughout. Well, now you've got yourself a preservation candidate. What if you've got sort of mostly low severity cracking, but a small percent of that high severity? Well, typically that's going to be localized. And so maybe you want to be doing some sort of full depth patching or something like that ahead of your preservation. Going down into, obviously, if you've got a lot of high severity cracking in multiple locations, especially if you're looking at that crack density either side of that 1/4 inch width kind of crack sealing line, if you like, then you're able to start saying, well, this is past it and there's no way, we want to do any kind of preservation on this thing. We're just going to be throwing good money after bad. In the wider sense, though, in pavement management, obviously, I've been talking very, very specifically about cracking, very specifically about, crack tracing and crack densities. Obviously, modern data collection also includes things like IRI and RUT and skid or texture information, things like that. So you're going to want to combine it with all that. So you have all that information at your fingertips as well. And then, of course, you've got coming online now similarly detailed, very high resolution information, like, for instance, traffic speed deflectometer data. And I think Larry also mentioned that. So, you've got a lot of other information that you can combine this with. And to end off, though, I just want to make one last kind of point here, and that is that there are limitations when you're dealing with distributions like this. Obviously, you don't want to model every single 6-foot segment individually. That's not what we're doing here. We're modeling distributions. But anyone who's kind of dealt with the new metrics in 490 there, and the performance period reporting that we've all got to do now, you're looking at your HPMS data, which is on the 10th mile segmentation. This is exactly the same problem. So what I put here was, note that 10% high severity cracking does not necessarily correspond spatially to, let's say, 10% high IRI. Those two locations are not necessarily in the same exact place. You can obviously see you start losing a little bit of visibility into exactly where the locations of that high severity stuff is. And if you're thinking about, sort of modeling in an HPMS sense for those federal metrics, this is actually exactly the same problem. When you're modeling on the basis of distributions, you do lose that spatial correspondence component. And that is my presentation. And so I put up here, think of them now, ask at the end, but I guess actually I ended up being last in the list. So this is the end. Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.